In order to understand the concept of stratigraphy, and therefore why it is so important to biology and our understanding of ourselves, it is necessary to understand its place in the field in which it is traditionally categorized, geology. In the West, we often associate modern geology with the Scottish geologist James Hutton, and without a doubt, James Hutton's contributions to the science have well earned him the name of the father of modern geology. But individual studies have been made throughout history, with the oldest recorded contributions being Aristotle, who originated the theory that Earth was changed by processes that were too slow to be seen in a single human life. During the medieval ages in Europe, the writings of Aristotle were rediscovered during the Islamic Golden Age and enormously expanded upon by the Persian Renaissance man, Ibn Sina. Elsewhere, in China, a scientist by the name of Shen Kuo wrote extensively on the concept of geomorphology, the principle that lies at the heart of stratigraphy. These rapid progressions ground to a halt in Europe when, during the 17th century, the prevailing theory of the formation of the Earth was placed solidly in Christian thought. This theory revolved around the concept of the world's geology having originated from the Great Flood, as described in the Bible, and stratigraphy, a concept that was in its infancy at the time, was used to provide proof for the existence of it. Stratigraphy is a concept and principle that is found primarily at the root of sedimentary geology, or geology that focuses on rocks created from matter like sand, ash, or pebbles. Its name comes from the chief formations within, called strata from the Latin word for layer. Indeed, strata are particularly easy to see when traveling through a road cut such as the one in the picture, or in places with deep riverbeds like the Grand Canyon. In these cases, strata are clearly delineated in different colors, with each one the result of a different geologic, climatologic, or even biologic influence. Stratigraphy is therefore the study of these strata and their formation, with the most basic law in the science being the law of superposition, or that the oldest is deepest, although there are certainly many exceptions to this rule. In the theory of the Great Flood being the origin of all geology and geography, it was believed that all of the stratigraphy that could be abundantly seen throughout the world was proof that the Earth had at one time been covered in one great ocean. The fossils of animals that could be found in varying strata were explained away as having instead grown directly in the sediment as it was deposited. This explanation held for almost a century, until it was questioned by the man who would later become the father of modern stratigraphy, a bishop by the name of Nicholas Steno, who, in 1659, issued a broad critique of this analysis and reinvigorated the concept, first posited by Aristotle, that there was no possible way that these geologic formations could have been formed in the time or manner that was given by Christian ideology. This reason given for this critique was rooted heavily in Steno's personal observations and experiments with stratigraphy. This scathing repudiation, combined with the rapid increase in importance of precious metals and minerals in Europe during the 18th century, led to an equally rapid increase in the popularity of geology during the time, which ultimately led to several competing theories as to the Earth's origin, with the two primary ones being Neptunism, essentially a rehashing of the Great Flood, but from a scientific viewpoint, and Plutonism, pioneered by Hutton, which proposed the molten Earth scenario that we now know to be the one favored by science. The final piece of the puzzle as to why stratigraphy is a principle that is heavily rooted in evolutionary biology comes into play in the beginning of the 19th century in Britain with three important figures: William Smith, Charles Lyell, and Charles Darwin. William Smith was a mining surveyor who, while completing a geologic survey of Britain, realized that the fossils found within individual but indistinct strata were an excellent method of telling how old a particular stratum was. Across the Channel, a team of French scientists led by Georges Cuvier was coming to a similar conclusion. The eventual publication by that team and the publication of the survey by Smith in 1815 led to the influence of stratigraphy in the thinking of geologist Charles Lyell. Charles Lyell would later heavily use this biostratigraphy, the scientific name given to the practice of dating strata by the fossils found within them, as the foundational part of his magnum opus, The Principles of Geology, a book that set off a geologic fervor in Europe that would eventually lead to Charles Darwin being both a declared geologist and also the naturalist and geologist on board the Beagle. Not only did Principles of Geology, which Darwin read on the Beagle, provide the perfect impetus for Charles Darwin to apply the gradual alteration of the Earth to the biological life on and within it, but it unknowingly provided the most concrete evidence of evolution, the fossil record. With stratigraphy as its groundwork, and with the law of superposition as a guide, it is now possible to actually see the speciation of species over time, but more than that, to track that speciation through geologic strata. During Darwin's time, this was difficult to accomplish, but as science has progressed, the fossil record and the surety that stratigraphy provides has become absolutely fundamental both in evolutionary biology and in our own personal brand, anthropology. Combining all of these theories into a single scientific understanding led geologists like Hutton and Lyell to an exciting and terrifying conclusion. The Earth was impossibly old, impossibly variable, and nowhere near done with its development. The complete repudiation of Neptunism and its later variant, catastrophism, removed human experience from the equation of how old the Earth actually was, and ultimately led entirely to the greater pursuit of our origins and the origins of our planet. Bringing this full circle, in an extremely modern use of stratigraphy, the Perseverance rover, which just landed on Mars in February of this year, is currently on a mission to, among other things, find evidence of microbial fossils in the Jezero crater, a task that it will accomplish using what is in essence a high-tech version of that used by geology hundreds of years ago. It will be drilling cores out of Martian rock and ideally returning them to Earth on a future mission, and should fossils be found, thanks to the knowledge of stratigraphy that we have developed here, we would even be able to tell when exactly the species that created those fossils disappeared. Stratigraphy is a concept that is surprisingly simple, merely the result of time creating opportunity, climate creating sediment, and gravity creating rock. But like math or letters on a page, stratigraphy is the language of the Earth. It describes every catastrophe and cataclysm, and once it was understood, it could be opened and read like any book. More than this, stratigraphy provides the record of the organisms that lived and breathed upon the Earth's surface, with the simplicity of it providing valuable insight as to the life and death of entire species. With its understanding, we were able to, for the first time in our history, truly realize just how extraordinarily short the sum of human experiences was in the grand scheme of the planet beneath our feet. It is simultaneously a drive to learn more about our origin and a humbling reminder of how much came before us. Thank you for listening, and I hope you enjoyed.